Good afternoon. In this video, I'm going to demonstrate an integration of Ansible Tower, HashiCorp Vault, the Vault Agent, vCenter, Cisco ASA, and Cisco ACI devices. So what are the prerequisites for setting this up the way we did it? You need a HashiCorp Vault cluster. You would need secrets for your connections to vCenter, Cisco ACI, and Cisco ASA stored in a KV version 2 secrets engine in HashiCorp Vault. And you would need the Vault agent configured and running on Ansible Tower, and the Vault agent would need to have access to the secrets in Vault. So our design for this project is to start a deployment from Ansible Tower, retrieve the secrets from HashiCorp Vault. Using those secrets, connect to vCenter and create a VM. Then attach that VM to the ACI EPG. We have to get the IP from the VM in order to know what the IP address is. Then we insert a contract into the Cisco ACI with a filter to allow traffic. In the Cisco ASA, we push a new NAT and security rule to allow traffic through the firewall. And then we check if the website is up or not. And if it's down, if the website didn't start successfully, we destroy the resources, remove the firewall rules, remove the contracts from the ACI, and so on. So let's get into the code. So we start out with a playbook that has 5 separate plays in it. The first play gathers the secrets from Vault. Then it uses the first secret for vCenter to talk to vCenter and create a VM. Then it connects to the VM and installs the web server packages and the web server files and starts the web server on the vCenter VM. Then for the third play, it connects to the Cisco ASA device. Then for the fourth play, it connects to the ACI device. And as the final play, it checks the status of the website for successful response. So I'll show you a little more in depth on how these tasks are working. So first, with Vault, we collect some information from Vault. So getting a token to talk to Vault that's stored on Tower that the Vault agent has retrieved and written for me. Then I call the API directly to get the secret in the path where the secrets are stored for this project. Once I have those secrets, I write them into a variable for each secret. So the second step is that we provision the VM with vCenter. And this task can do double duty. It can create the VM or destroy it. So depending on whether we're in the forward moving part of the playbook or if we're tearing resources down, the same task will be used. And it essentially sets up the VM and the resources it needs. Then the next step is to install and configure our web server on our brand new vCenter VM. So we'll install Apache and copy over the files that are needed to run the website. And then it'll start Apache, so the web service is running. Once those steps are done, then we talk to the Cisco ASA device and we configure the object for this new web server. Then we add that host into the object and configure the public NAT and an access control list for the device. And then on the Cisco ACI device, we create filters. Ansible's first step in ACI is to create filters in an ACI tenant to restrict traffic to only the HTTP protocol to and from our endpoint group. And in this case, we set up an endpoint group that only contains our work from home public IP addresses and of course Tower, because Tower needs to be able to read the website when it's done. After we create the filters in ACI, we build a contract, and we'll create a new contract in ACI, add the subject, and associate the filter that was created in the last step. Then we create a new external EPG and apply the new contract. Ansible will be building a new external EPG that we use to classify the subnets which are external to the ACI fabric. In this case, we use our work from home IP addresses and restrict the inbound traffic to them. We also apply our newly built contract with the filters included to the new external EPG. This will effectively limit the inbound traffic over port 80 to this web server and only to the IP addresses classified on the external EPG. And the last play again is a sanity check. It checks the website for a successful response. When combined in a Tower workflow, we can reverse the process and tear down the VM, the ACI and ASA configurations, and revert the process. So we kick off the workflow and it calls the playbook for the provisioning process. The first thing it needs to do is update the project and check for any new code. I haven't released any within the last half hour, so it should go pretty quickly. So it already read the information from HashiCorp Vault, and it's just provisioned the virtual machine. Now it's adding the VM to a group, and it's installing the web server on the VM. Now it's starting its configuration of the Cisco ASA device, setting the NAT. Now it's building the ACI filter and the ACI contract and the EPG include and the external EPG. And then it associates the contract to the EPG. It tested the website and the website is up and successful. So here we'll go and take a look at this website that we just set up. And it's very happy. It's there. So thanks for watching my video today. I hope you enjoyed it or learned something from it. Have a great day.